But let me start off by saying that big data is different for everybody. Big data architecture is the framework that governs the types of data and the methods that that data is integrated within the organization and its database. Without infrastructure, big data can't exist. The infrastructure determines the capacity, and not all technologies can answer all business questions.
Okay guys, so I'm going to take you through a journey of our company and how we transitioned from a wonderful product to being big data experts. Now if you own a business, you know that you have to have some sort of competitive edge, maybe a competitive edge in a new product or a competitive edge analytics-wise. Our company, Mongodb, is going to do both. I'm Scott Michelson. Over here we have Jim Halpreet, and this would be Dwight Fluke. So I have to warn you, this next slide is going to be a little bit graphic, so if you're queasy, please close your eyes, and I'll let you know when you can open them. Jim Halpreet, show the next slide. Oh. How many of you have had a paper cut in your life? How terrible has it been? And here at Mongodb, we're here to solve that. So Jim, can you show us the revolutionary technology that we were able to create?
Are they ready? Are they ready?
Are you ready? Here's a microscopic level of the type of paper that we can create. Paper cutless paper. Now you never have to worry about carrying a stack of papers from class to class after the printer at the printing lab or giving them to your boss to deliver. So now we have our great product, we have our differentiating strategy, and we're ready to hit the market as a paper wholesaling company. Next slide, please. So how did we start our business? We have extreme domain knowledge. We know all about our own paper industry, and we know that we have a competitive edge. But we only knew business first name basis. So here's Jim giving us some insight on to what normal business life looks like. We actually had to call our customers. We had to say, we would love to be your wholesale paper company. So as we start serving these small businesses, we were starting to use small data. And we noticed that as we were growing with our new revolutionary product, we needed to move on to the next stage. So we started collecting sales data on paper. Like any small business, we wanted to know when we could collect our money and how many contracts and clients could we hold at once using our books. So as we started to leverage these things, we noticed that we were gaining more market share, we were getting more clients, but we had growing pains that needed to be resolved. And on the next slide, we'll be talking a little bit about that. So me, Scott Michelson, had to come up with a new idea. So we had years of all of this data, right? But we had to do that data entry into Excel. And then from Excel, we were able to visualize this data. And then we were able to bring some insight into Mongodb with monthly sales reports. So we could see if Dwight Fluke was slacking off in his sales or if Jim was really killing it. And that way we could give some incentives during office time. And we could also see where we were being better than our competitor. And speaking of our competitor, staplers, right? We've all heard of staplers with their classic slogan, that was simple. And what staplers does really well is they completely cut out the calling centers, and you could order online. So as our company is growing, right, we're in the mid-2000s now, we needed to make our own website. And so we wanted to compete with them. We have a better product, but they have a better service. So we need to catch up to them to leverage our position. So as we did that, we've made our website, but now we have more data, which is the Rfm data. So now we can see, which Rfm stands for the recency, the frequency, and the monetary value. So how recent have they purchased from us? How frequent are they purchasing from us? And how big are their orders? And right here in the middle of the Venn diagram are the people that we want to be going after for. So as we do our data analytics in Excel and visualizing, we can bring up a list of our best customers and continue to sell to them. But unfortunately, Dwight Fluke, we hit a plateau. Staplers started to do the same thing, And Dwight Flute had a mental breakdown, and he came to me, and he said, we need to figure out a solution on how to go above the competition. So me, being Scott Michelson, decided that we're going to use analytics. And we actually had our friend Lionel Richie make a song for us, Is It Leads You're Looking For? So now we're in the realm of analytics, right? We need to get leads. We're going to classify calls as buyers or non-buyers, and then we're going to predict how much money they're going to be bringing us. And so what are the most important factors of these buyers and non-buyers? What are the things that we need to be tackling and going after as a company? So as we move into the next slide, we're going to be using Salesforce.com. This is something that's very simple for us to start out with. But then as we move into machine learning and maybe even Python, we're going to be making these classification models and then eventually these prediction models. But they can only take us so far. So now that we're in the new age of big data and we're competing against staplers, Munder Difflin is going to be turning over to Dwight Flute to bring us in to how we can use big data to leverage our company to further our profits.
Thank you. So in order to continue our journey in developing an infrastructure that's going to be able to harness all the data sources that we have, we first need to look at what data is out there. So the data that we have really consists of the historical data that we've been using for all the time. We have all of the data from our past sales, we have all of the data from our fulfillment warehouses, inventory costs, we also have data on basic competitor moves, and there's also data that we can go ahead and source. We don't know exactly how to use this yet, but the data that we can source includes demographic data such as the populations of certain zip codes, the incomes of certain areas, the locations of our competitors' stores. We can look at new house purchases, new business openings. So we can go ahead and target these businesses as they're going to have a need for office supplies. So these are just some sources of data that we can use in order to feed our new data architecture in order to better our analytic journey to be able to predict more sales. So one of the first areas of data that does not fall into the previous mentioned structured category is reviews of competing products. So using sites like Amazon and staplers, we can go ahead and pull reviews from an unstructured environment and then find out what type of sentiment is being said about certain products in order to go ahead and improve on these products to make them more valuable to us as a company by leveraging our unique products and just by making products that are more useful to our customers themselves. Another source that we can use is social media, and by that we can pull all the wonderful things people are saying about us at wonderful sites like Pinterest and Tumblr and Facebook and Twitter, and we can pull the sentiment analysis from these sites from an unstructured environment and find out what is making our customers really, really like to do business with us and see if we can target what that is in order to go ahead and capitalize on that. Next. But most importantly, what we like to do is we like to go ahead and monitor our customer communications. And by that, if you've ever called the company, and if you've ever called us, you would hear that this call may be monitored for quality assurance purposes. What this means is that we're recording all of our calls, and we're monitoring all of the emails that come into our company. What we want to do is we want to be able to house all of this information in an unstructured environment, but still have a database that's going to contain all of this data, so we can analyze this data on a real-time basis, do real-time sentiment analysis for what customers are saying about our company. With this information, we can then react to the good things that the customers are saying about us, target them with new promotions, and then also better react to customers that are potentially going to have an issue and correct that issue before it occurs. So in order to handle this unstructured data, we need to make sure that we have an architecture in place to handle this in the most efficient way possible. So basically what we're doing now is we're trying to figure out the best way to go ahead and store this data into a system that's going to be able to harness the breadth of the data, but also at the same time be able to go ahead and provide us the information that we need when we need it. So Chris is going to be able to tell us the competitors and what they're currently using and how we're going to be able to trump them.
It's Jim. So most of our competitors are using relational databases, and they're really trying to solve a problem using old databases. For instance, Microsoft SQL, IBM DB2, Oracle, for example. But most companies use these databases. For example, 48% of companies are using Oracle, 20% are using IBM, and 17% are using Microsoft. They do not handle all types exceptionally well, and it's difficult to scale or run analytics on top of this. So to further go into how SQL is handling big data, we have to remember that it's expensive, it's clunky, it's now legacy. Like I said before, it's not advised to run analytics on top of a SQL database. As most people have described the problem of a round business problem with a square coin. Square, what's that, shape?
Square.
Okay. So I want to introduce, thank you. I want to introduce NoSQL. NoSQL is our answer for running analytics. It is a non-schema enforcing data store, which we can basically store anything without requiring the use of a schema. This will differentiate us in our ideas, answer our business problems, and build market value and from our data. It's not only is it a column store like SQL, but it's also a document store. As Vince or Dwight highlighted, we can store hybrid bits of information. For example, video, pictures, and audio. So I want to introduce MongoDB. MongoDB is a document store. Like I said, we can store multiple types. It's very scalable, which was a problem in the past with running SQL. And there are a couple examples of other companies that are running it. That's Cassandra with Facebook and HBase Apache. Another point, the MongoDB is open source. So for our company that's somewhat small, we don't have to worry about the costs associated with Oracle's SQL. So these documents are stored in binary serialized documents. So we can iterate through all the files as fast as our infrastructure allows. And what infrastructure are we going to put in place? Will be Hadoop. Hadoop is going to be running on top of our MongoDB, where our analyst communicates through the use of MapReduce and Pig. MapReduce is a paradigm for processing large sets of data. It splits the data up into chunks, and it runs it through each node on the cluster. Pig is for controlling the flow of the data. Hadoop is a software framework that enables massively scalable storage. So we can grow, or for instance, our database can grow as the data comes in. And we have to remember that we're recording audio and text and all this unstructured data, so we don't want to have to worry about implementing the schema as the data comes in. We can just set it to record as much as we want and look at it later as we find relevant questions to answer. Also, it should be noted that Hadoop will be our data warehouse. So we're kind of answering multiple questions of where we're going to store it, how we're going to process it, and how we're going to pay for it. Hadoop is free. It's the servicing that costs a lot of money. The next point is ETL. ETL is extract, transform, load. And that will be the point in which we are taking our unstructured data, determining what kind of value or what kind of questions we're going to answer, and loading it into the Hadoop cluster. So we're going to use that. We're going to use ETL through MongoDB to communicate with the cluster to answer these questions. We could use programs like Talent to extract the documents from MongoDB, to transform them, to do whatever we want through MongoDB. And we could also build applications on top of the Hadoop cluster using a programming language of our choice. For instance, Java or Python. I think you could use C++ if you want. But it's really up to the designer to write a program for that. So our original idea was to build our market, or really grow our market share by answering the questions of our customers, and those were the sentiments. So if we can figure out what the current sentiment is and answer, really change our business to reflect the sentiment, and hopefully it's good all the time, but it tends to fluctuate, then we could really differentiate ourselves from our competitor. So we decided to build a dashboard. And this is a dashboard, this is really a programming running on Hadoop, which will consistently be pulling the data through the application that was built in Python or SQL. Actually, this was Python. So we can see here, we have overall sentiment. We have word clouds. What are people communicating to our customer service representatives? What are they talking about? What are they talking about? Are they talking about paper cuts? Are they talking about the level of brightness? Are they talking about the weight? We can figure all of this out if we have the ability to iterate through the documents in a fast and efficient way. We can remember that, like I said, this is not free, but the hardware is the expensive part. The software is inexpensive. It's really the controlling the connection between the hardware and the software that most of our money will be spent. Here's an overall slide of what the process is. If there are any other points from my associates to bring in at this point, I feel like now's a great time. But overall, we're connecting an unstructured database, or really a database that's a document store, to a data warehouse, Hadoop, to run applications. And those applications will build market share.
So now we've taken our company, Mongodb. We have an innovating product that started us small. We had a little bit of Excel work that got us going. We started using predictive analytics that got us ahead of the curve. But now we're ready for the next level of innovation. We're ready for big data with our infrastructure that you see here. So I believe in Mongodb that our paper-cutless paper is going to drive market share, and big data analytics is just going to be a part of our company. Thank you.
Thank you very much.
Questions,
Any
teams?
questions?
Teams?
I don't see any. All right.
Whose finger was that with the paper cut?
We had to hire a hand model, so that was kind of expensive.
I'm just curious. When you say you can do big data in SQL.
We can't. We were saying that our use of iterating through unstructured data is not advised.
So it's not that you can't
in
really use
SQL.
SQL, it's just you can't not for what you guys are trying to do with it.
Which was sentiment and audio analysis.
Great. Thanks, guys.
Last. I think we have time for one more.
I like the idea of the open source tools. I keep hearing the word free thrown around. Where would you say the majority of the costs associated with these types of projects would be in terms of your evaluation of understanding the setup of the infrastructure and those type of things?
Overall costs.
Where are the costs?
Associated with-
Where would the costs come
Yeah, what
from?
kind of costs are we talking about?
with our current implementation.
Yeah, I mean, I hear free, open source, and where do I sign? But I want to know what are there any costs associated with it?
So, I mean, you can download Hadoop, or you can use Hadoop. And we actually did with our Hadoop workshop. So that level of analysis is free, but obviously if you're going to be a huge paper company like Mongodb, you are going to need a lot of infrastructure. So using servers and...
well, depending on where the company already exists, it may be a good idea to set a goal. If you want to ingest all the data that's out there and process all the data, it's going to be exceptionally more expensive than if you're focusing on recordations from your customers. So Hadoop is running on infrastructure that can be inside your office if you don't want to be paying someone like an Amazon or a Microsoft or any of the cloud services. You can implement it on absolutely anything you want, but you have to be concerned about the speed. So your speed is essentially the speed of the hard drives, because it's the document store. So it's the time that it takes to receive the document, and then the computational power, which will be your processor. So if you have those already in place, it might be cheaper than you think, but it's the cost of the human resources that you have to consider. So if you're going to hire interns, obviously it'd be less expensive than industry experts, but you might be able to grow with the resources that you're planning to hire. I would consider human resources to be the most expensive of the project.
Interesting. I'm not 100% convinced I'm going to go with a big data solution. I'm still thinking of maybe of a more traditional sort of data warehouse and data mart. Which would which would probably be more expensive or provide me a quicker ROI, or do you have a sense of which one would, the two questions? Those are two different questions, right?
What's your goal, though?
It's your company. I'm just asking as a consultant.
We're still focused on extracting information from our unstructured data sources, correct?
Well, extracting, presenting, making decisions based on actionable insights, right?
Absolutely.
Okay. So would you recommend that I go with a big data solution, or would it make more sense to go with the traditional, which may be a little bit more known?
We would actually recommend that we stay with our Hadoop-based solution here, simply for the scalability aspect. What we're looking to do is we're looking to implement something on a small scale at first, and with a Hadoop cluster, we can do this with a small number of clusters, and then grow this exponentially as our business grows, which we fully expect it to do with our paper on this paper.
So it's worth the investment.
It's highly
Absolutely.
scalable.
All right. Also, would you show me the dashboard that you guys had up there a minute ago? Would you say that a pie chart is a really effective visualization for this type of dashboard?
So this is just something that our lowly data analysts, we had to bring on some new workers. Unfortunately, they had to give us pie
They
charts.
missed the presentation.
We promptly fired them for this pie chart. And Munder Difflin is a better company for it.
But do you know the levels of green that are highlighted in the sentiment pie chart?
So a pie chart necessarily is not terrible when it comes to two variables. So green is going to be your better color. So if we had one layer there, that would be positive. It's a quick visualization that can say, hey, a majority of people are liking our paper versus roughly 25% are not.
And
I
here-
do agree with you, pie charts are not the most effective.
Next to the pie chart, it's hard to see here, but if I look a little bit closer, there are statements that are determining what makes up that pie chart clearly. And the last one says great buy, great purchase, great service. So the great will essentially make that statement positive and will just be added to the pie chart. So you don't have to rely simply on the pie chart alone. You do get the comments right next to it.
I can see you're a data visualization expert. I appreciate your feedback.
That explains it completely. I appreciate it. Thank you.
I'm glad we answered your question.
Thank you very much.
No more paper cuts.
All right.
Nice job, guys.
Next slide, the next one?
Yes.
Yeah. So, is there a reason why you don't have the feedback loop, the iteration from your data presentation outcomes to back to your data source? If there are problems with the data, then do you go back and the feedback loop going from your last vertical
All right.
layer to back to data source?
To making adjustments to the source.
Yeah,
It-
I mean, because
I understand why you want
I
that
think
here.
monitoring, so this might be a product sheet, right?
Yeah, because that's
Right, but if you operationalize it, then the operational framework needs to have some way of tracking what's going on, how good we are, what are we missing,
like here.
right? So in your architecture framework, if you don't have that feedback loop, I mean, it might be something.
So you're saying making adjustments to the,
So based on what you get out of your
The
data
data source.
presentation there, and just what you found in your the previous chart.
are you asking us a question?
Yes, I'm asking you a question as to why that feedback loop was missing, or is it required, is it necessary, or do you need it? Or?
Well, we decided not to put the feedback loop in at first, because we wanted to see, by using a large amount of manpower, to see exactly how it was going to perform against an actual real-life environment. Once we scale this up and automate it to a much larger extent, we are going to have a feedback loop in. So once we do get these dashboards, we can then adjust the data that we're pulling out of the Hadoop cluster to reflect better and more information the customers are actually saying. So yes, I think the feedback loop will be implemented, but we're just trying to show the smallest scalable solution currently.
Okay. Is that it? All right, good job.
Thanks, guys.